midpoint of YV and WZ. We're supposed to prove that VWX is congruent to YZX. Okay, so VWX is congruent to, this is not real hard to see, but we'll just look at it anyway, YZX. Okay, so what we know is that X is the midpoint of VY and WZ, so we want to mark that. VY and WZ. Okay, it's the midpoint of VY, so that means this side is congruent to this side. And it's also the midpoint of WZ, which means this is congruent to this. Okay, so I have two sides of these triangles. Now, what are my different things I can use to prove congruency of triangles? We have side, 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 angle, side, angle, angle, side, angle, side, angle, hypotenuse, leg. I think that's all of them. Okay, so looking at side, 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 do I have anything that would tell me that ZY is congruent to VW? Is there any reason they have to be, other than that we're trying to prove that they are? Nope, nothing. Okay, what about side, angle, side? Now remember, the angle is in between the sides because it's got to come between the sides. Is there any way for us to prove, and we're going to use a different color because the red is the part we know, but could we prove that those two angles are congruent? Yes, we could, because we know they're vertical angles. All right, so let's write the proof. We're going to start with X is the midpoint of VY and ZWZ, and that is given. All right, now you have to come out and say in so many words that those segments are each congruent. So let's do that. Vx equals xy. Vx equals xy, or is congruent to xy. And wx is congruent to xz. And wx is congruent to xz. And that is the definition of a midpoint. Or you could write out a midpoint divides a segment into two equal parts, if you really want to. All right, now, we know these are vertical angles, but we have to say it. Number 3, Vx, we can't say angle x because there are several angles there at angle x. Vxw is congruent to zxy, and that is vertical angles are congruent, or the vertical angles congruency theorem. All right, and then we can say what we're trying to prove. And since we're not fools, we're going to use the exact statement they have there, number 4. That's what we're trying to prove, so that's what we're going to write. Could you write these differently? You could, but it said prove this. So to not look like total idiots, we're actually going to use the exact words that they give you. And why is that? Side, angle, side, congruence. No, I'll make it so that you can look at the whole thing together. Handwriting's not so great. I'll have to work on that. Okay, moving on to the next one. Write a 2-column proof. Start by marking your figure. AK is congruent to CJ. That's the only way I know to mark that. BJK, BJK. You know, if I do this in red every time that I'm marking the given stuff, that might be less confusing for you. AK is congruent to CJ. BJK, BJK is congruent. I guess I don't need to mark that way. BJK is congruent to BKJ. And angle A is congruent to angle C. And we're to prove, and this is very important for you to mark, prove ABK is congruent to, I'm going to use a different color so I can see it, to CBJ. Okay, so the first thing we're going to do is look at what we know. We have an angle of the green triangle congruent to an angle of the red triangle, and another angle of the red triangle congruent to an angle of the green triangle. Wow, it's pretty good. Okay. Angle A equals angle C. Okay. So, we have two angles, and let's remember what we have to choose from. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And hypotenuse, leg. Alright, how can we prove? Can we do anything with these sides? Oh, sides are already said to be congruent. That makes it really, really easy. Because it already said that the sides are congruent as well. So all we have to do is say all that stuff. Alright, this is kind of lame. This probably isn't the one on the test, or one like one on the test. You might not find that. Statements. And reasons. Okay, AK is congruent to CJ. That's number one. It's given. I guess I'll put all the given together. BJK is congruent to BKJ. Oops, BKJ. And angle A is congruent to angle C. We could just use one letter because there's only one angle there. Okay, and then we're going to prove triangle ABK is congruent to triangle CBJ, and that's because of angle, side, angle. It's really easy. Okay. PQ bisects SPT, oil treatment. Oh, that's STP. And then SP is congruent to TP. First thing we want to do is mark that stuff. We're going to mark it in red. PQ